Okay, yeah, so we're going to go over schematic libraries and probably also PCB libraries, because I feel like we can manage all of that in the hour. Like I've kind of been mentioning within these past few months, what I've been working on, kind of what we have now. Phantom library. We do have, in our GitHub, we have a repo for the Phantom library that I've put together and mostly have set up. So there is a full repo dedicated and libraries dedicated for each of these components. So for the most part, our board should be built off of this, but there will always be the case when you have to create your own components, or if it's a new design and we don't have the parts, you have to add it into our existing library. But the libraries are filled out with components of different sizes, so 0402, 0603, 0805, 2512s, all the different sizes, all the different ranges. So we do have quite the setup of components, but we will go over how you would create your own library, or if you wanted to add in a fresh component to our existing library. So first off, if we just wanted to make our own new library, separate from everything else, file, new, library, and then we're just going to make a schematic library for now. Now for basic, or for your standard components like resistors and everything, you do have the ability to fully actually create your own. So like you'll actually draw these zigzags. Whereas if it's something like, what am I going for? An IC. Easiest thing is just to drop a rectangle and throw the pins on it. You don't have to be fancy. But if you are creating a new resistor or one of these simple components that have, I want to be making this. If we just wanted to be making a new component like a transistor or something, I find it easiest to just go copy paste the symbol from another schematic library and paste it. Otherwise, you can place pin, and then place lines. So you could draw this out yourself and do it as you please. But I find it easiest if you're doing something like a resistor capacitor or something that has a symbol from a different library. Just copy paste it, because it's more effort than it's worth to try to create your own symbols. And then if we wanted to make something that's not a standard component, so maybe we wanted to make converter IC. Should have started this off by actually pulling up a datasheet for one. Buck. Yeah, sure. We'll say we wanted this one. Let's get out of here. I'll just pull up an actual schematic so we can see it proper. So say we wanted to create this new dot converter, throw it into our library. First things first, know your component, go to the data sheet, and they will always give you the pin assignment. So you'll get a little diagram and all the pin labelings. And most of the time, for most components, they'll give you a typical application so that you can see how they throw out the pins. So we can follow that and create our own. Let's do it that way. We can create our symbol similar to it. One thing to notice, what we use in Phantom is for our preferences. We use millimeters because I started designing it and I prefer millimeters over mils. So when making new components to throw into the Phantom library, we want to make sure we're staying on millimeters as well. Otherwise, there will be offset issues when you're making a schematic, and it makes it just slightly off, but annoying. So if you're making components for Phantom, or in general, if you're making new schematics, new libraries, you want to make sure that you're always keeping your units the same. So don't create a couple components imperial, a couple components metric. It'll just cause misalignment issues. I also prefer a grid of 2.5 millimeters. But we can do PR for place rectangle. Same, you can just come to the top bar, place rectangle. Click and drag. Right off the bat, just throw down a block since you don't know what size you want. And we want to copy this layout pretty similarly, just since they give us a nice design layout, so might as well follow it. So place pin or PP. And when you're placing pins, start off at 1. Always make sure you start off at 1, because you'll find that when you start going, you can do 3 on this one, jump to the next part, and if you place pins again, it keeps counting from wherever you were previously. So now it'll do 4. If we were to jump back, no, I guess not. 1, 2, because it already had. You don't want your pins starting at 4, because when you look at your true components, you want to make sure you're lining up your pin numbers as they do. This will matter when you start to make the PCB library. You will find that you have to make sure your pins match the same as on your PCB and your schematic. So we wanted let's start with the symbol. So we're placing a pin. Our designator is 1, and our name for this one is going to be, so pin 1 EN. And when you're placing a pin, you notice the crosshair right now is by the 1, it's outside of the component. You got to make sure that's how you place all of your parts. If you were to place it this way, the electric, so when you're doing your schematic, would have to be all the way back at this end of the pin, because this is where the connection is actually considered. So if you were wiring your schematic and you brought your trace only up to this point, that won't mean pin 1 is connected. So that'll just be considered a floating pin. Whenever you're placing your pin, you got to make sure that the crosshair is on the outside of your rectangle. It's also easy to notice that your name goes inside. So whenever you have name, so EN, that falls inside of your component. Do something else. Any questions as I just start filling this in?
So whenever we make a new component, we need to start with pin number 1?
Yes, you always want to start.
Sure.
Also, you press spacebar to rotate it around. So if you're placing on this side and then you jump to the other, double space, you're on the back. Small screen is a little annoying. Let's see. And we do have to make sure we place a pin. This chip has an exposed ground, so they consider the exposed pad of this component to be an extra pin, pin number 9, even though it says it's an SOT5 or whatever this one says it is. Yeah, like this component says it's 8 SYC. We do have to consider that the exposed pad does count, so we have to make sure we put a 9th pin, which is P ground. Now this is obviously not the best looking one, but we can fix that. So right now we just followed exactly how the physical component looks in terms of pin orientation. So 1, 2, 3, 4, 5, 6, 7, 8. But if we look at the schematic, see that they have VN over on the top left, so they put their pin up here. They have their feedback here. The reg is also down. So they shift their pins around. So you can see in our actual schematic, we don't have to follow going 1, 2, 3, 4 up to 8 all the way around. numerically like it would be on the physical device, but we can lay it out in whatever manner we deem cleanest or best for us. So one thing with that, the kind of standard to go with, let's see if I can snip. Let's just bring this one over. So the convention is power goes top to bottom, while signals go left to right. And that generally is like your input and your output going from left to right. And then for power, it's usually your, don't have to be 5 volts. It'll be like your VCC or V in, and then ground on the bottom. So that's the typical convention, schematic layout in general, being put all of your input signals to the left and your output signals to the right. Obviously, you can't do that always, and it doesn't work out all the time, because you may just have an absurd amount of output signals that you're not just going to flow it all to the right side. We'll only have one pin on the left. So there is, make it work with as you can, but this is kind of the standard convention. And so what it generally looks like is power in top left, grounds in the bottom right, and then inputs, outputs. So you can use that for whenever you're making any kind of IC or multi-pin component, that you try to keep this convention. But it's not always 100% necessary. It's as you choose to design. So with that, we will follow with that. So we want to make sure our block is big enough to actually hold everything, being all the way up. And it's better to oversize your footprint or your layout a little bit. Better to have it more spaced out than tighter together, because you can imagine you can make a real small, compact component, bring all of your pins right in, have it all overlaying, and it'll make for a small footprint, but it becomes, you would absolutely want to avoid any overlap. So at the very least, it needs to be spaced out enough that you don't overlap. But then you also want to make sure you space out your pins vertically as well, because there can be, you'll often have times when you're actually laying out the schematic. So if we look at this, like we have a capacitor going from the BST to the switch pin. So if we are to if we space these pins out enough that I don't have capacitors open. Let's just say it was supposed to be a resistor that goes across. We space it out enough that the component can fit perfectly between your pins. Then you don't have to worry about doing any snaking with your schematics, and it can make it look a lot cleaner. So that your wiring, what am I doing? Place line. Your wiring could just be straight up pin to pin, and then this pin would go off. Pretend that's a capacitor, so that it can look similar to this. Just nice, clean, blocks off and walks away. Where if we were to have our components tight together, and then we wanted to do this, well, now we would have to go, and then it'll loop out, and it'll loop out, and it just looks a little more off. Sometimes you can't avoid it, especially with large pin. If your package has a lot of pins, you can't use a full schematic for one part. So sometimes you have to make that compromise and bring in your pins tight together. But when you can, it's nice to, if you know your design, especially, if you can space your pins so that your connections will be a little easier, a little cleaner. I am going to drop it down still, though, just because I think we can work with it. Okay. Any questions on like the pin layout, positioning, and all that kind of stuff? Any questions on the hotkeys I'm hitting? Because I know I never go up and I hit place anything. Everything I use shortcuts for every component I'm placing. Or is there a list of show all quick commands? I am sure there is. I can't remember how to pull that up on Altium. Probably didn't want that. I'm sure there is. I can't remember the actual. I can't remember the. There is a list form somewhere in Altium, but I can't remember where it is. I could probably find it and post it in the chat after. Anything else? Jay's typing. Yeah, so whenever you're making components, if they're easy, proper, just diodes, resistors, transistors, something that is something that just has the standard symbol, you can draw it out. Easiest thing, going to an old library, copy paste. And then if it's something like an IC or multi-pin chip, you just place a rectangle and then pins on the outside. Yes, in general, for all of the projects that going forward, it's going to be preferred that everybody uses the Phantom library parts. But if you have a new part or it's just not there, you need to make a new one. You can do it yourself by following these steps, or if you're just doing a completely non-Phantom related project, this is how you'd go about. Okay. So that's how you make the parts. And if you want to be fancy, Faraz has actually been really good with this. These are mine, so don't take that as his. When you have comparators, inverters, something you can do if you have your two inputs and your output pin. Inside of the rectangle, you can just do place line or place polygon, bezier, any of those arcs, whatever you want, and you can just internally draw some symbols, just so like it would help your understanding of the schematic if you put your logic gate symbol inside the schematic.
I thought like we have like IEEE tools for
that. Sorry, what?
The IEEE. I think like we have like some of, they do have some of them in their tools. Like for like logic gate and stuff like that. Oh no.
Like in Altium's tools that can do logic gate stuff?
Yeah, I think the place or some tool something. I think there's some IEEE Explorer.
That's a solid. I don't know. I've never done it. Close that one. I didn't want that. I've always just done it myself. Is what I wanted. Yeah, like Ross has done it really nice. You would just always put logic gates wherever you want, and it makes it a little cleaner. Let's close that. I don't want to see you. Yeah, so if it's something like that, it's really nice and easy if you want to make symbols like that to make it easier to understand. IEEE symbols. Yes. Yes, so there is the place IEEE symbols, and you can use org. They have some of the things. If you don't want to draw them out yourself, there's a bunch of different symbols, different drawings, if you wanted to incorporate it in yours. Anything else on the symbol itself? Okay. Then the next important thing to this is the naming convention. So we have our component. If we double click on the name of it over in the library tab, and then go to general, it's the name that we gave it. Designator. There's a big list of the standards. So for resistors, it's R, capacitors C. For multi-pin chips, ICs, and all of those, it's typically just U, and then you do question mark. By doing this letter for whatever the actual symbol is representing, so in our case it's an IC, so we say U, and then we place the question mark. The question mark is there so that later on in our schematic design, when we go to annotate the schematic, Altium automatically knows that it needs to replace the question marks with an appropriate number. If you just leave it as U, it may not know, and if you were to right off the bat say, I want this to be my U1, then then it's going to automatically be U1. If you place multiple of these, they would all be U1. So you obviously don't want that. So the easiest thing when you're creating your library is just give it its designator letter and a question mark. And then for what I wanted, whip it up. There's a couple ways you can do your commenting and description. Best thing to do for your description is when you find your part in DigiKey, you just straight copy paste the description it has. So that'll be your description. And a good kind of system that we run is you take your manufacturing part number and you make that your comment. That didn't copy the right thing. The manufacturing part number is your comment. And most of the time, we would even put it as the ID. Or if not the ID, we could call this, because we know our application, we wanted it to be a 12 volt down to a 5 volt buck converter. So we could call this maybe it's broken, buck 12 to 5 volt. So you could call it something quick and easy like that, buck 12 to 5 volts. So that way, when you're going through your library, you'd be able to find the component easily just saying buck 12 to 5. Yep, that's what I'm looking for. For the libraries, I did it a slightly different way just because organization. So I went with saying the part size and then the value. In the, like if we just open up any of these, we can see the designator ID is the package size and then the value. That's just so it's easy to find when you're skimming through all of these. Your designator are question mark. Your comment is 2K because this is a 2 kilo ohm resistor. And then the description is exactly as it was in DigiKey. I just copy pasted it. You want to make sure your comment is really reflective of the part. So for capacitors, inductors, resistors, having the value of your component, so 2K or 1 micro, whatever it be here, because when you put these on the schematic, it's the designator and the comment that show up on the schematic. So you don't want this to, you don't want the 0603 2KR, or you don't want the description to show up in the schematic itself. You just want a short comment of it's a 2K resistor. Back to our library. So yes, name it something how you would easily find it. Letter question mark for your designator. Comment either the manufacturing part number or the component value. And then description, copy paste from DigiKey or wherever you're pulling it. Questions on the naming convention, labeling, all of that stuff? No, it's all good. Okay. then the next thing we want to do is we want to take this part and we want to have it linked to a true component. So what we can do is if we copy the manufacturing part number, and then we go into part search, throw that into the keyword and search it. It'll give us the component from a couple different manufacturers. DigiKey is typically at the bottom. And since DigiKey is what we use for the most part, typically go down, find that one. You'll often see that there's a couple different DigiKeys. The difference between them may just be that it's a tape and reel versus so it can be a tape and reel, a cut and tape, or a digi-reel. We want cut and tape because that's how you get low component values, low unit orders. If you do a tape and reel, it'll give you a lower price, but you have to buy 2,000 of them minimum. So we obviously don't want that. So you'll notice that when you're choosing your link, there may be several different ones. They may be at several different prices. It's just going to mean that they're showing the different packaging types. Often it's not too big of a deal if you were to put the tape and reel link in, because when it brings you to this page, when we're selecting the quantity and everything, we can just be like, no, I meant cut and tape. I only want 10 of these. So it's not too big of a deal if you link it to the wrong part. But that's what we go with. So we want DigiKey. So right click. I want to add the supplier link and the parameters. So we can close this. So we can see now in the supplier drop down, it now has a component linked with, there's a link, there's a price, there's its description. So we know our part is now linked to a real DigiKey part. And we notice that it printed out the part number, or the manufacturing number. I typically don't want to see these because we already gave it a comment that we want to see. So to get rid of this here, again, double click on your component and then just go over to the parameters. And you can just scroll down and you'll see that typically like the supplier part number, the I will be unchecked, so it wants to see, so we just tick that off. We don't care about seeing any of these values. They give us all of the parameters, current, voltage, package. They give us everything. We don't care to see that on our schematics, so we just hide them all. Makes sense. Now we want to make sure that we always link, if you're adding a new thing, you link it to a physical part. That way, when you finish your project and you're exporting the bill of materials, everything's going to have a price and a part number, so you don't have to worry about missing a component. If you don't do this, either we'll make the mistake and we'll order and you just won't get this chip, or you have to manually go in, search for it in DigiKey, make sure it's the proper one, and then add it to your list. So best if you just always make sure you have the part, the supplier linked, so it has all of that info.
Wait, sorry, I missed. How do you get to the part searching part?
I have mine tabbed up on the right here.
Okay.
If you don't, you should have the panels in the right of your screen.
Yep.
And it should show the part search here.
Okay.
Have it tabbed up somewhere else.
Okay. Thanks.
Yeah. So if you notice you don't have any of the tabs that I have open on my sidebars or the bottom bars here, you'll be able to find all of them in the panels tab. So part search, and then
you just have
Sorry, go ahead.
And you just have to have the part open to link it. That's all you have to do.
Yeah. So when you're working on this component, you just go digikey, and you just copy the manufacturing part number.
Okay.
You just copy that, and you go part search, and then throw it into the bar and search.
Thanks.
Using Altium Designer function. Is it bad that you're using Altium 20? No, it's okay if you're using Altium 20. Better if you're using Altium 18, because I know there is some differences to 20 compared to 18 that I just may not be able to help you with, or it won't have the same compatibility or the same layout. So it's better if everybody has Altium 18, since that's that's what most people have. So it's better if we all stick with it. But there's no problem if you do have Altium 19 or 20. Yeah, you can just uninstall and then reinstall Altium 18. No problem. It doesn't cause anything. Any other questions on linking, naming, schematic layout? Okay. Then the final thing about the schematic libraries is adding a footprint. So this is to bring up a 3D model for your component. If you don't have any libraries, obviously you can't do it. So what you need to also have is file, new, libraries, PCB library. So here is where you make the 3D models of all of your components. And for the most part, it's nice and easy. Let's hide that one. So we can go Tools, IPC Compliant Footprint Wizard. This is what you'll use most of the time, because it has, the ball grid arrays, it has the quad flat packs, it has 2 pins, so this would be your capacitor, inductor, resistor. It has everything. So what we are looking for.
Out of curiosity, like when you're not using a compliant whatever, is that when a company is actually making their own like silicon chips or something?
No. Sometimes you have to make your own footprint, even for known components, just because Altium doesn't have everything. Like one example of that is headers. like if you're just making your simple jump point headers, there is no wizard footprint for that. So you have to manually just place the multiple pads and do it yourself. And I'll show you one of the other, what I wanted to pull up. One of the components that I may show you is this MOSFET. Like it is a weird surface mount 5 DFN or a 8 SOFL, which has just like 4 nubs on one side and then a large flat pack. But you won't find that in here, so you have to manually make that one. So there is just sometimes it doesn't have every single possibility, but it has most of the standards. So yeah, you just have to make those then. But for right now, we're going to make our buck converter, which is, what did I say? It's an SOIC. So it's an SOIC exposed pad. Yep. First thing you always want to do is generate step model. That's so we can actually, so it looks nicer. I mean, you don't have to do this. And I've forgotten to do this on a couple components as well myself. But it just changes from having a gray block with pads to having something that actually looks like a legitimate part. Gives it the legs, gives it the symbol. It just makes it so your model looks nicer in the end. But now we have a big list of parameters that we have to fill out. So we go back to our data sheet. And basically every data sheet will have its package footprint on the base. So we are doing yes. So we were doing the EDFM? No. We were doing the SO8. So everything we need to know is here. And where is that gone? Let's cancel this so I can just kind of mind. Tools, wizard, SOIC, generate the step. I bring up this. So, and you'll find that most of the time, the labeling is going to be the same most of the time, but sometimes it's not. Like we can see the wingspan on this, they call it E1, where Altium calls it H. So don't just scroll over to this table and go, okay, I'm looking for A, throw an A. A1, throw an A1. When you're going through, do make sure like you're looking at, okay, what's my width range? They're saying it's H, so they're talking about the wingspan. Here they say the wingspan's E1. So I'll go over, it's 5.9 to 6.1. So 5.9 to 6.1. And you'll just go through the full data sheet. So sometimes they want the min and max. Sometimes they only care about the maximum. Sometimes the data sheets aren't this nice. sometimes they only give you what the typical value is. So they don't tell you what a min and max could be. They'll just say your width range is 6. And then when you're only told what the typical value is and you have no reference on the min max, what I like to do is just plus minus 0.1 or sometimes 0.2 depending on the part, just so there is some tolerance. So if they only told me 6, I probably would have put in 5.9 and 6.1 anyways. So I'm going to run through filling this in. Any questions as I just start filling this in? Let me set this 8-pin. Now, do you guys think if I just did this, I made sure if I just left it as this and a nice ugly block, would this function as a device? I'm saying I have 8 pins. Would this work?
Dude, the agreement after Pam finishes this game, I'm going on the computer.
Nobody want to answer?
Could you ask that again?
If I just left it at this point right here, I didn't bother finishing the rest of these parameters. Would this be a functional part for me?
No.
It looks lengthy.
Yeah. One of the
That
things.
part wouldn't fit, right? On the pad.
Yeah. Well, one of the things actually is if I left it at this point, 3.5, I would actually be okay because of all SoC packaging having the pitch of 1.275. And I mean, we can see that here. Our little e is the pitch between pins is 1.27. I think I said that wrong. So even though our body length is 10, it's not stretching out the pins to be all that way. It's only allowing the pitch to be fixed at 1.27. And since we properly put in what the height and the width is of the packaging, this would actually be okay because the pads are where they're supposed to be. But the model looks ridiculous because it's overhanging a lot. But technically, this going this far would actually make it an okay part pad-wise, but it is just ridiculous. And obviously, sometimes you may not catch that. Like if you had to put in the pitch yourself and it was randomly set at 2.5, then yeah, 100% you wouldn't be able to fit this. So you do have to make sure 4.85 when you're doing this. You make sure you fill in all of the components, all of the numbers properly, hitting the proper numbers. Otherwise, yeah, you can run into, if you misread what and got your E and H backwards, so you made the component a little thinner than it should be, then your physical pins aren't gonna reach the pads you made. So You always got to make sure you're watching all of the components you're putting in. But stuff like the maximum height, that really doesn't matter. So this could be a nice super tall component. It doesn't care because we set our body width and our body length, which are the real determining factors. Those are set properly. So height is more when you're looking at mechanical constraints of enclosures and such. But regardless, you want everything to be proper and laid out as it should be. Should we go over to the next page? And we want the thermal pad. So we'll do these as they should be. 275. Okay, so these are already in the proper numbers, just based on how they were before. And then you can keep hitting next, and you'll see that Altium is using calculated values. So you don't have to look at the data sheets to find everything. There is some stuff that Altium will do automatically, so it knows default values. It'll use what you've already given it and give the calculated tolerances. It'll do all of these on its own, so you don't have to do everything. Most of the times, everything that you need to fill in will be on the first page, or at the very max, it'll be on the first and second page. That'll basically be as far as you need to go. But it is good just to cycle through to make sure that, okay, now it's starting to use calculated. I'm done looking here. So I can just finish, and it gives me a nice component. We can see it gives us a nice 3D model. One important thing that you need to consider when you're making these is that the pinout is proper. So we can see it goes 1, 2, 3, 4, 5, 6, 7, 8, and then the center is 9. We can see that 1, 2, 3, 4, 5, 6, 7, 8, center is 9. And we have this identifier on pin 1, top left, just like we have it here. There's an identifier on the top left, right beside pin 1. That is important to make sure because sometimes, especially for MOSFETs, I'll say MOSFETs. Like if we were looking at this one, like I brought up before, it is a MOSFET, so it only has, the 3 terminals. But when you look at the physical packaging of it, it has 1 gate, and then it's source, 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 drain, 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 drain. So when you're making this, you have to make sure that when you're making it and since your schematic footprint is only 3 pins, 1, 2, 3, you can't make a footprint that has, pull that one back up. We can't make the footprint that has, 8 different pins labeled 1 to 8, you want to make sure that you would maybe label all of these S pins as 2. So it's pin 2, pin 2, pin 2, pin 1, and then pin 3, pin 3, pin 3, pin 3. That way, I should just bring this up, because I think I made this one. Questions as I'm just looking. Yeah, so this is the footprint for that MOSFET. So you can see I labeled pin 1, and then all 3 of these are labeled pin 2. All 3 of these are labeled pin 3. So that when you link it to the schematic footprint, it knows pins 1, 2, 3 without being confused. Questions on, where's this? Questions on any of that? Making the footprint? Nothing? Okay. So I'll hit on, if we wanted to make, I kind of brought this up, if we wanted to make a header, since there is no option for a header in the footprint wizard, this is something we have to manually make. We would do place pad. And this, again, this is where you can see issues. Like this automatically wanted to start at pin 9. But if my schematic is starting at pin 1 and I want those two to match up, I have to make sure that I call this one pin 1 as well. And then I would just place however many holes, however far apart that they need to be. Again, this would be looking at the datasheet, and it would tell you that these two need to be, 2.5 millimeters apart from each other. So you would make sure that this one's on 0, 0. And then you would put this one at, 5 and 0. You can change whether it's a rectangular or circular hole, if I want my hole size to be larger, and then the actual pad of it that larger. One thing to make sure you're doing when you're making, because these are now, that's your 3D model of it, is this is the exposed copper that you actually get to solder to. So if you were to make a 1 millimeter hole, and then you made the annular ring 1.1, you can see that you have very little to actually solder to. Compared to these guys, you have a good couple millimeters to solder to, or 0.0 millimeters. So when you have to make pads for headers or any other through-hole components, you find what your minimum hole size is based on the datasheet, and then the pad size, at a very minimum, go at least 0.5 greater than your hole. I think there is a proper there's a proper recommendation. I think that might be a little larger. But regardless, at a very minimum, you want at least 0.5. Shoot larger if you can, if you know your components are spaced out enough that they allow it. So in our case, we could get away with doing 2mm rings on both because there's still enough space to go between. But if your pads were, 1.5mm spaced out, you obviously can't get away with having such a large ring. Otherwise, they just merge together and you're instantly creating a short. So there is, make it as large, at least half, at least 0.5 greater than the whole. A little bit larger if you can make it, but there is a limit, since sometimes you probably also want to run a trace through between the two lines, so you don't want them too close. What are we at? We're just over an hour. Okay, let's go back to the final. I'd have to save everything. So if we have, so let's say we just made our component. This is an old one just because I don't want to save all of this work. We would go back to add footprint, browse, libraries. And since I'm not in the project, it also doesn't want to do that. Give me a second. Now if I do browse, so you'd go into your library, the PCB library that you made, you would scroll through and you would say, I was just making that S8 SOIC. So I know this is my component, so hit OK. And then you can see on the bottom that it'll show your model. You have an 8 SOIC footprint, and it gives you the little preview of it as well. So you know it's all linked up together. That will do it for this one. I'll touch up on the PCB library a little bit more in the beginning of the next lesson, but any questions on mostly the schematic library for today? Nobody? Anything? I know most of you should already be familiar with the schematic library. It is the first thing you need to be doing whenever starting a project. And moving forward, we're wanting to just be using this phantom library. So you potentially don't have to do any more of the creation of this. But clear to everybody on how to make components?
Yes.
Can I get confirmation from anybody else, or yes, Raphael? Okay.
Should be good.
Okay, yeah, so that will do it for this lesson then.